Water, water everywhere. But have you ever stopped to think that maybe it is nary there is just a fruitless drink? Well, actually it isn't. And it is. Water is a special and important molecule for life. Let me explain. Water has several properties that make it so essential to life, at least here on Earth. Cohesion, adhesion, being a great solvent, and how ice floats on liquid water. This may be confusing, so Mr. Hamilton here will explain it for you.
Hi kids, it's Dan, and I'm going to teach you about adhesion. Now first, I'm going to put this piece of paper in the water. Now adhesion is the property of water that makes it want to adhere to other things, like paper. Now, if you look at the paper, the water has moved up the paper. You can't see it very well probably, but I can tell you, it's pretty high up there. The water moves up the paper because of adhesion, but it also moves up the paper because all the water molecules behind it are pushing it up. And that's because of cohesion, which Sally the Salamander is going to talk to you about right now.
You see, water wants to stick together even though nothing physical is holding them together anymore. This is thanks to the hydrogen bonds between the different molecules, where the hydrogens, being less electronegative than the oxygen, attract the partially negative oxygen. This may be confusing, so think of different ends of water like a magnet. Back to our friend Mr. Hamilton Maverick to walk us through a quick experiment. Water has what is called a high heat capacity. You see, kids, this means that a lot of energy needs to go into the water for it to get warmer, and a lot needs to come out to make it colder. It's like when you're tired and move slower until you wake up later in the day and had breakfast and moved around for a while. This is why you can walk outside in the winter without matching the temperature of the air. Water is special. Water can take in lots and lots of energy before changing states as well. This means that water can boil pasta without turning into vapor first. This is called high heat of vaporization, and it also means your body can get very cold without turning into an ice cube in the winter. Just like how it takes a while for you and your class to get in a straight line to go to the cafeteria. Back to our friend Mr. Hamilton Maverick to walk us through a quick experiment.
It's me again, Dan. Now, I heard that Sally just told you all about water's ability to take in heat. And guess what? I'm going to show you what that looks like right now. Now make sure to get a parent if you want to do this at home. All you're going to need is a thermometer, some water, and of course, something to heat the water up in, and some ice. Now, the first thing I do is you got to boil the water. And then this water has already been boiled, and okay, there's no vapor, no nothing. It still looks just like regular water, and it is, oh my, 190 degrees. Can you believe that? Water still looks just like it did. It looks like you only take a big sip, but don't, that'd be dangerous. Now look at this one. This one looks just like regular water too, doesn't it? But this one I put ice in a few minutes ago, and now it's, oh my goodness, it's 36 degrees, and it's not ice yet. This is why you're able to put spaghetti in this water and make it all soft and ready for macaroni and cheese, and you're able to put stuff in this one and it stays nice and cold. Now back to you, Sally. These kids have a lot more to learn.
Hold on now, there's only two more. Next, we're going to look at how water is a great solvent. Have you ever seen salt disappear when you stir it in water? That is because water's molecules are polar, just like a magnet. Salt is polar, and so the opposite poles of water adhere to the salt and surround the salt molecule. Because water relies on the fact that the substance is polar to dissolve it, nonpolar molecules cannot dissolve. This is the same reason why oil and vinegar don't mix well, because the oil is a nonpolar lipid, hydrophobic, and so doesn't dissolve in water, or vinegar for that matter. Back to Mr. Hamilton for another fun experiment featuring the solubility of water.
Hi kids, it's me again. I'm going to teach you an experiment that you can do at home that's all about solubility. Alright, all you're going to need for this is 2 things of water and 2 separate things. Salt and oil, and a spoon. Okay, step 1. You take salt, just regular table salt will work, and it's poured. Now you just add tons of it. You're going to just unscrew the cap and just pour salt in. And now, you can still see it, but look what happens when I stir it. It disappears. The water just looks a little bit more white. Now look what happens when I pour oil, which is not poured, into the water. Look, it forms, and then even when I stir it, it stays out of the water. That's because oil isn't poured. Here, how about you see it from the side?
And last but not least, we have how ice floats. Ice, which is frozen water, is a crystal. You may have seen snowflakes and how they have uniform size that make pretty designs. This is because when water freezes, the molecules line up in a lattice structure. This is called a crystal. When this happens, the molecules actually spread out, which makes the ice less dense than liquid water. Thanks to this property, you can skate on lakes in the winter and life can survive underneath it. Otherwise, lakes and oceans would freeze solid, as the top layer of liquid water keeps freezing and sinking. Well, Mr. Hamilton, what activity do you have for us now?
Hi kids, it's me again. Now I'm going to show you how ice helps. Alright, let's pretend this blue lid is ice, and then the water is water. Now this ice, as you can see, it's floating on top of the water. Now, can you guess what the fish do in the winter? That's right, they have to stay in the water because fish can't walk on land. And because this water on bottom isn't top, they can still swim around. They just go into hibernation. And that's why fish are able to survive and other animals can survive in the winter. Because the ice will stay on top instead of going down. And it's going through a cycle of freezing all of the water and killing all of the animals. Now back to you, Sally.
Now you know everything that you need to know about the properties of water. I'll see you all next time, and remember, stay slick.